This video is super optional. It's not that important. I want to talk about some of the some special notations for integers and floats that you'll encounter, or maybe you'll encounter. The first one is this underscore we can actually use for both integers and floats. Instead of a comma, which we often use, at least in the US, we use commas to separate out groups of numbers. Like if we have a billion, or let's do 31 billion. This is how I would write that normally. Well, that's 31 million. There we go, 31 billion. If I hit enter, I get something entirely different. What this is something we're going to learn more about later on in the course. It is not just a number. It's actually four numbers in this grouped structure. It doesn't matter. It's not what I thought I was entering. Those commas mean something different to Python. So I can either do this, where I just smush it all together and make sure I get the correct number of zeros. I think that's 31 billion. Or I can use an underscore. And this allows me to separate out not just zeros, but separate out groups in a large number. And then hit enter, they're completely ignored. It's purely there for my sake, my human sake, not for Python's sake. So that works for integers and floats. Not really something you'll see much, but it's good to know you can do that. And if you ever see that and you're confused what's going on, just think of it as a comma. Separating out the different groups of numbers. Another thing to know about ints is they cannot start with a zero. A leading zero is going to give us an error. So I can do 9, but 09 gives me an error, and it's a very specific error. It says leading zeros in integer literals are not permitted. Now, I can have a leading zero in a float, like 0.8. I can also just do 0.8, though. So either one is acceptable, but in an integer, 0.8, not valid. It has to be the integer 8. And the last thing around floats is that sometimes we'll actually see numbers in scientific notation. Now, if you're not familiar with scientific notation, it's not worth sweating over. It looks like this here. And you may encounter this, like if I enter in some long float here, let's say something like, well, let's do something with a bunch of zeros to make it easier. 0.00000. Well, that wasn't enough, of course. How about that? There we go. I've got scientific notation here. This is just Python's way of representing this number that we see right here. So this is totally valid. I could actually enter this in and get the same thing out. It's the same number. It's just a different way of referring to it. So that's one situation. You may see a scientific number, and that doesn't mean you did anything wrong. It just got to the size where Python decided it was better to display it using scientific notation. But we can also enter numbers in this format. I pretty much never have done this, but you definitely can. Like if I have 6.7, and then I can do e to the negative 10th. And there we are. Let's maybe do e to the negative 3. And there, we can see the corresponding full, fleshed out decimal number, no scientific notation needed. So again, this is all very optional. This is why I made it optional. It's not that important, but being comprehensive here, you can use this scientific notation. And that's it for this video.